Hey, welcome back to episode 35. Today's going to be another good one. This is part 2 of the wheelbarrow build, or power wagon, or whatever you want to call it. I spent most of my week collecting all of the parts that I'm going to need for this one, and there's some ups and downs that came along the way. Like for example, this is a spindle assembly I got from the Dodge Neon, and some tires I got from the Wrecker as well. But we'll explain a little bit more along that as we go. And you know what, it's a nice sunny day, so I think I'm going to do a bit of the layout in the front driveway, and then I'm going to go into the backyard and grab the materials that I need for it all. Now, I need a big beefy shaft that's going to go between these two wheels, and I have just the piece of material sitting in the, no, not the one on the left, but the one on the right. Now, this 3x6 is just perfect. And I'm going to have to scoop up the shop dog in training and put him in the house because I don't think he's really shop aware quite yet. Now, I did some dry layout in the front driveway, and I came up with about 4 inches sticking out from either side. Anything more is going to be too wide. I mean, this thing's going to be 4 feet wide in total when I'm done. And anything less, obviously the tires are going to rub in the frame, and that's not going to work very well for us. Now, I mean, this isn't going to be going at 100 miles an hour, so, I mean, reasonably square is kind of what we're shooting for here. I mean, I know I did take the time to machine all the bearings and fit them in, but that's more of a weight thing than anything. Now, if the tires are out a couple millimeters on either side, I'm not really too worried about it. The key here is going to get a bit of tongue weight on the center joint, and that's choosing where I cut, and then figuring out how much it's going to extend out. This will all make sense in a little bit more. This is where the pins is, and this is where the pin's going to be. And then the pin's going to extend out from the actual snowblower, and then it's going to kind of look like this. Well, that's enough of the yard art. Let's actually roll it up and show you what it's going to look like. Now that you have a good idea, and I've got a good idea, I'm going to cut about 4 or 5 inches from center over so that the weight's, like I said earlier, on the tongue. See, if I didn't have any tongue weight for this, I wouldn't be able to get traction on the back wheels. And if you have too much weight a little bit too forward, I mean, you could end up flipping it over forward, and it could be a whole dangerous situation. And if you're having some trouble following along right now, part 1's going to make a lot more sense to you. I mean, it's only a 5-minute video, and it'll make it all come together. This, what I'm actually putting up here, is actually going to be the top of the dump box, but I'm going to use it kind of as a welding table to keep everything straight. Now, if it bows up a little bit, I'm not overly too worried. I mean, if it's like maybe 1/8 of an inch bowed up, it's not going to be a big deal. It'll be more visual than anything. Because really, what the weight's being held across by is that big beam there. And the rest of it's just kind of a supporting weight. And then on top of this, later, in the next video, I'll throw an 1/8 inch plate on top of it when I build the bucket. Now, we're kind of shooting for rockstar welds here because we don't want this coming apart. So I'm going to clean up everything. I mean, clean the rust off, clean the paint off, and make sure I have metal to metal transfer and none of the garbage in between. It's pretty possible I might go back and throw a couple passes over it later when nobody's around just to make sure it's all welded up real good and tight. The key to this project, though, is to make sure those end caps that I'm going to build later are welded on real good. Now, this is an old electrical vault, so, I mean, it was really only just tacked together. So I'm going to have to go back and grind out all of the joints to make sure I get the paint out, and then grind the top surface of the paint off, and then throw a really good bead over top of it, melting it all in. And I'm also definitely going to put a 45-degree chamfer on any of my new welds to make sure they're not going to break off, and I at least get to the middle when I weld it. Now, we're shooting for close to square here, but in keeping in mind, we're also looking for productivity too, right? I mean, I can't spend all of my time trying to get it absolutely perfect when it's just a wheelbarrow. So I'm going to tack it in 4 places on every joint, and that way when I actually throw down the heavy weld, it's not going to pull to one side or lift or whatever it does, you know, all the welding science. And I'm going to wind up with a good product in the end. Now all we got to do is figure out what plates we're going to put on the end and drum up those Dodge Neon parts that I got from the Dodge Neon. Remember when I fell in love with that Dodge Neon out in the yard, at the scrapyard? I mean, I absolutely fell in love with this car, and the parts were cheap. And I mean, it was sunny out. Well, no, it was raining. And truthfully, this is where it kind of turned to crap a little bit. Bolt holes with an end mill because they wouldn't come off. And then cut the other 2 off because it was just easier. You know what I'm talking about. You've had these projects too, I kid you not. After spending about 2 or 3 hours getting that all sorted out, it was the wrong part. I thought it looked like this, not the other one. Guess where you put those. Let's jump in the truck and head down to NAPA, and let's buy some new parts and stop messing about. I narrowed the search down to either a Chevy Sunfire or Cavalier, or I was going to get them from like a, I don't know, like an Impala or Malibu. But, I mean, it all comes down to cost, right? I mean, I got to talk to Gary down here at NAPA, and I think he's going to hook me up. Now, Gary jumped on the magical computer, and within a couple keystrokes, he figured out what was going to be best for me, a Chevy Cavalier, nonetheless. Now, let's get these bad boys back to the shop and have a look at them. Now, these are way more cost-effective than I'd actually imagined. I mean, if you were to buy an industrial bearing, it would be super pricey. Then you'd have to build the hub, etc., etc. Now, these ones here, I think are pretty reasonably priced. And I mean, I got a pretty awesome deal on them. But this is the way to go for building something like this. The only challenge that you might have if you don't have a machine shop is you're going to have to cut a hole before you drill the hole flange, or it's not going to work very well because it'll be quite a standoff. What are these extra parts that come with this too, by the way? More junk for the junk drawer, I'm pretty sure of it. All right, let's open this up and have a look. All right, we got, what's this? O-ring. Some kind of seal. Should I put this in the junk drawer? Nah, I'm not throwing this in the junk drawer. But we are going to save that. Now, let's scribe this out. Now, I have a junky pair of venereal, oh no. I have a junky pair of vernial calipers, and I use these generally for scribing. So, if you don't know how to do this already, basically you measure your width, divide it by 2, and then scribe both sides. Now, I describe both sides because if you're ever off, you'll know right away. Then we're going to pin punch it, then we're going to take it over to the lathe, and we're going to bore a hole in it in the lathe. Now, if you own a machine shop or a lathe, or you're a hobbyist in the backyard, you need one of these. This is something I built, and every machinist needs to have. You got a 4-jaw chuck. Basically, just stick the pin in the center, stick your tailstock up, and then when you spin this bad boy around, watch this. You know exactly where your center is. That's right, super duper simple. I mean, you're probably thinking to yourself, I should have thought of that. And you know what? I didn't think of it either, man. I had some machinists tell me this one too. I think it was Pat from BCIT. He showed me this one. He was my Red Seal instructor back in, I think, like 98 or 99. Let's plug this bad boy in, and let's drill some holes and make some chips. Now that we got the center hole drilled, let's push it right to the limits. I mean, we don't have to drill that thick of material. It's not going to get too hot, so let's grab the 1.5-inch drill bit, I think. And we'll jam that through there to get a really good start at this all. This, coincidentally, is one of the ones that I found at the scrapyard. Remember back in one of my other videos where I found some in the scrapyard? Well, this is the same drill bit. And they've been working out pretty darn good, I'll tell you what. Remember, boys and girls, it's all about feeds and speeds. The bigger the hole you drill, the slower it goes. I mean, unless you got a lot of money and you can just keep pushing drill bits into it. But, I mean, this is the way to go. Now, you see the one chip coming out the one side there, and then the other one not coming out? The drill bit's not in the super best condition, however, it's still drilling quite well. And the blue that you saw when it was coming out, that's just because it was pushing through the other side, and it usually happens when you have a thin material being drilled. Now, we're going to jump over to the boring operation. This is the boring part of the video, is probably what you're thinking. I assure you, if you're new to machining, there might be a little bit to be learned here then. So what I'm going to do is I'm going to hog a bunch of this material out. Of course, we have to get to 3 inches and a bunch of change. So I'm going to cut it to, say, maybe roughly about what looks like 3 inches, and then I'm going to start measuring. I mean, a professional probably would have measured first, but this is what I'm going to do. Now, let's grab those calipers and have a measure here. So I'm going to measure this, and then I'm going to zero it out. The purpose of this is, now all I have to do is measure the hole, and it's going to tell me exactly how much material has to be taken off. Truthfully, I'm just looking to get this within 3 or 4 thou, so it doesn't have to be super precise with inside micrometers and stuff like that. I mean, the millwright side of me wanted to grab a torch and cut a hole in it, but then the machinist side of me was like, no, you should probably do it right. The machinist side of me is a little bit more logical, but tends to waste a lot more time, and the millwright side of me is a little bit more gung-ho and breaks things from the odd time. So now I've cut about a 1/2 inch off, and because of tool deflection, sometimes you can have problems with, like tool wear or whatever. So I usually bring it within, say, 180 to 200. And hey, look at that. It's 204 I got left. And that's a reasonable amount that I can cut off in a finishing pass. Okay, well, I'm going to cut 100 thou off and then creep up to it with 250 thou cuts. And this is going to give me bang on what I'm looking for. I did run into a little bit of a problem with it, however, is on the inside of that bearing, there was a bit of a chamfer, or like kind of a rounding. And the purpose of that is, in the bearing manufacturing, is that so you don't have a sharp 90-degree angle and it won't break. More science, but either way, today I basically cut a chamfer in there and then pushed this bad boy on. I'm really starting to feel like I'm making headway, especially after yesterday and the nightmare that I went through with the Dodge Neon parts and what have you. Now let's do some sketchy shit, see if it works. And I live to tell the tale again. Let's head over to the milling machine. Remember these parallels I made in one of my other episodes? Well, they're coming in handy, actually. And today, they're just going to raise this part off the bed just enough so that I can get a good grip on it and yet not drill holes in my table. Now, I have 2 of these parts, and I want to get them close each time. So I'm going to use this ruler here just as a side stop, just to make sure that it's roughly close every time I dial these parts in. Now, before anybody gets crazy about cosine error and all that stuff, dude, we're just making a low-speed car here, so we don't need to worry about like science and math and geometry and stuff. So this is going to work quite well for what we're doing. So basically, if you don't know how to dial something in, it's super easy. Obviously, it's pushed to one side, and we need to find center. So this little tool here is going to help you find center. That little lever on there, when it gets pushed down, the needle goes up. And then when it goes back, the needle goes down. So easily, you're going to go over to one side, and you're going to make the needle go up halfway, because it's halfway to the center, and then you're going to go back and check it along the way. I threw the north, east, south thing on there just to give you an idea of how it kind of works. And then as I creep back to the south side, I'm going to meet that in the middle as well, kind of a cheat from the east and west. Generally, I'll only waste my time dialing in the 3 sides, and I won't spin it all the way around the world until I've got it within a couple thou, or bang on just to double check. In today's case, I thought I had it banged on, but I ran around and guess what? It was out a 1/2 thou. Okay, well, this is a metric tool, but you kind of get the idea. It was cheaper on eBay by at least 20 bucks, because I don't think many people buy metric tools. But I mean, it works the same, so, well, you get the idea. Now, we've got 3 holes we got to figure out, and we have to figure out what our bolt hole circle coordinates are. I'm going to do this by finding out the distance between the first 2 centers of the holes. And then I found this really cool calculator. I'm just going to plug that measurement in with the 3 holes, and it's going to spit out the other measurement. Then I pump it into this calculator, and it's going to give me what my coordinates exactly are. And then we're going to put this bolt in here. I'm just double checking to make sure this is actually a 1/2 inch by 13 bolt, because I do have some metrics kicking around in the drawer. And the wall chart that I've got says 27/64, and we're going to double check, because sometimes things don't go exactly back where they belong. Now, if you had some really, really, really high-end parts, you would drill this hole before you did this, just to make sure that it's actually on size. Because sometimes you don't have a sharp drill bit and it drills way over and everything's put. Now, this calculator actually was pretty darn cool, and here's the moment of truth to prove it all to you. These are pretty tight bolts, and to tell you the truth, The ability to actually be able to thread this in by hand, that level of precision, was pretty good. And they all three would thread in by hand, and only if I torqued one down with a wrench would the other ones get tight. But, I mean, that's just science for you, and it torqued it off to the side. I am pretty darn happy with how this is turning out. Let's go back out front and weld this bad boy on. Now, the only problem that I had with welding this on was, well, the bearing was kind of sticking out. So I just had to cut a notch out with the grinder, and there would just be a little less meat holding it on when I welded it on. But I mean, you got to break a few eggs to make an omelet, or cut a few corners, something like that. You kind of get the idea. Let's cut her off and weld her up. Now, one of the key things when I'm going to weld these on is I'm not actually going to take these bearings off. And for you tradesmen out there, I mean, there's all kinds of warning signs going off, especially for the particular fellas that don't like wrecking bearings. But what I'm going to do here is, I mean, this is all 3/8 metal. I'm just going to stitch weld it on in increments. I mean, of course, I'm going to tack weld it on first, because that's the smartest thing to do so it doesn't torque off to one side. But I'm just going to stitch weld it all on. But before we do that, we need to make sure that it actually will fit on there. Because I've had so many projects where you measure everything and calculate it, and then once it hits the road, so to speak, it doesn't fit. Something rubs or it's a little bit too far out. And this is the time to find that problem. Lucky for me, the measuring was really, really close. So let's tack weld this bad boy on and see what we can do about getting this done today. So now that I've got this tack welded on, I'm going to full send it. I'm pretty happy with the way it looks. And there's a few safety violations here, I'm sure. I mean, there's no welding jacket on, no gloves, proper gloves, and I don't know, multitude of safety things. So don't do as I do as you do, and you'll probably be a lot safer for it. But I assure you, while I'm welding this up back to my project, that this part doesn't get hot enough to wreck the bearings. I think 60 or 70 degrees is too hot for bearings, Celsius. And that's when you start cooking all your grease. And if I can't put my hand on it, then it's probably too hot. And it turns out I can put my hand on it. Now, keep in mind, I did weld this in stages. So I welded one side, then I waited a bit, then I welded the other side, and I waited a bit. And it worked out quite well. And if you don't believe me, I'll put my hand on it just to show you. Yeah, that's good enough. The true test isn't until the rubber hits the road, so to speak. Now it's just a matter of bolting these two wheels on and seeing how it all works out. I kid you not, it is extremely difficult to be a decent family man right now and not to pull an all-nighter all weekend finishing this cart. So I think today we're just going to bolt the wheels up and roll it around. And I'll give you a dry mock-up. I'll show you what it's going to look like. You see the gray thing, the square thing that looks like a picture frame behind me? Well, that's going to be what our dump box is going to be made out of. I'm just still processing exactly how I'm going to get that dump box to work. And I'm probably on the next video going to focus on, yeah, that's right, hooking this up to the power cart. Well, okay, this is the power cart, but we're going to hook it up to the snowblower and see how it works. Let's flip it down on its wheels and see how it rolls. I mean, if there was too much in tow, it wouldn't roll very good. And also, hey, you know what we should do? We should roll this around a bit, and then we should check to see what it's going to look like once we put the snowblower actually on it. The only thing is I can't figure out whether it's going to go this way or that way. I mean, it all depends down to kind of clearance. But I'm pretty sure this is the way it's going to go, because it'll give me a bit of separation between the box, and it'll let that bottom frame hang a little bit lower. Now's a good time to like and subscribe the video, because you know what? There's going to be a few more videos coming out down the pipe that I'm sure if you hung around this long, you're going to absolutely love. Or click on the link that you see in the video here and check out one of my other videos.